welcome back. As usual, if you can turn on your cameras, I will appreciate that to show your faces so we can move forward. Now, for today, I want to continue talking about user stories. I want to continue talking about requirements. Again, it's the first step. We want to provide software quickly. We want to deliver a first version in the first sprint. The key idea to start is understand what the customer wants. So, stories. Previous lecture, I showed you examples of mistakes, things that are not good stories. The invest principles, things that do not follow those principles, either because they are not small or they are too small, valuable, independent, testing, estimation. We talk about things. And I focus my points to errors, mistakes, to review your assignment, to evaluate your global knowledge. Today, let's do the opposite. Let's talk about the process to follow, how to create good stories, what do we need to do to obtain good results. I am going to talk about it. At the end, you're going to have homework. Homework, assignment number 2. I am going to ask you for the requirements of a project. Again, as I did before with the Pac-Man, I am going to talk about the project as a customer. I am going to tell you what the project should do, what are my expectations for the project. I am going to talk about the graphical user interface and other things. Your work with your team, tell me the requirements. Create user stories. Small challenge. This time, I am doing the teams. I am going to tell you who is going to be working with you. You are going to work in teams, 5 people, but I am the one doing the teams. So I will let you know who are in your team. My goal is that a lot of the process, the problems to solve, when you are collecting requirements, involve discussion, involve several people talking about one idea and taking a decision of whether or not that is a requirement, whether or not that is correct. Something that I want to do this time at least is asking you to work with random people. I make the teams randomly, well, alphabetical order of your name, really. So maybe there are a friend there or 2 friends or more, but maybe not. And when you work with your friends, you are going to agree with whatever your friends tell you. There is not going to be a discussion. So I create the teams this time, hopefully to increase the possibilities for you to discuss your ideas with others. A reminder, you're going to submit as a team. It's the same grade for all the members in the team. Please, you are going to have 1 week to work. Schedule time to talk with your team and to agree that whatever you submit is the result of all the members of the team working together and agree that that is what you want us to grade. Do not wait until after the due date or until you receive your grade to tell me, Professor, that solution, that answer is because my teams created. I do not agree. So can I have a better grade at them? Remember, technical skills and team working skills, soft skills, communication. So this is your opportunity for practice that. Whatever you submit is the same grade for everyone. If you have the correct answer, be sure that that correct answer is what is going to be submitted, please. So I am going to talk more about that at the end, but first, the process. Previously, we're here. I am going to explain this, what product I want, and I want you to move forward. And now in particular, I want you to create stories and I want you to use the template. I am going to describe that. Later we can program. Stories, writing stories. steps. Number one, I am going to ask you to review a project that is not like the Pac-Man, that is not common knowledge, that is going to be something new. The first thing that you need to agree with your team is no assumptions. Do not assume that, oh, I think that I understand whatever. If there is something that you do not understand 100%, if there is something that in your team of 5, 3 people think one thing and 2 people think a different thing, that is an opportunity to talk with your customer. Ask. Again, after your submission, after you receive the grade, do not come to the TA, this is what we understand. This is what we as a team understand, so that is what we submit. Ask, because the TA is going to be grading according with the user requirements, what the user understands, what the user wants to tell you. If you do not ask, it's a mistake. You are not collecting requirements in the correct way. So maybe the main point in red, do not assume things. Questions, ask directly. Now, I do not know how you are going to split the work with your team, but it could be a very bad idea to use, you know what? You do 5 requirements, you do another 5, you do another 5, I am going to do 5, and 1 hour before submit, we put everything together. Whether or not you do that, we're going to notice. And again, it is better for you to meet and review what your teammates are doing before the submission instead of sending appeals later. The appeals basically are going to be, we are sorry, you are the team, you submit this. So team project, ask questions, please. That is going to be your assignment, the key. Moving forward, where to start? Number one, you have the description of your project. You have whatever the client tells you. Step number one, ask yourselves, in this problem, in this project, who are the actors? Who are the entities involved? Which elements are those participating in the system? Identify what is called the actors. Let me be clear. I am not talking about the users. I am talking about the actors in the system. Those entities that inside of the system are the ones that have the control of the story, the control of what is going to happen. For instance, in the Pac-Man video game, can you identify the actors there, the roles, the entities involved in the system for the Pac-Man video game? Maybe can we agree that one entity is the Pac-Man? Thank you. Following with the chat, you give me the idea. You have the Pac-Man. The Pac-Man is exactly the same as the user, the player. You can use the name player, user, or Pac-Man, but we're talking about exactly the same entity, right? I mean, the player is the one that is moving around the maze. The Pac-Man is moving around the maze. The player is moving around the maze. The Pac-Man and the player are the same element. In the system is the Pac-Man, clearly. The other one, the other entity, the other who, obviously is the ghost. The ghost, you call it the system also. The ghost is moving alone. The ghost is intelligent. Well, you can think about the system, the computer, something inside of the machine is moving the ghost. Actor number one, the player. Actor number two, the system, or the Pac-Man and the ghost. Those are talking about the same. Why is it important to identify the actors? Because then the next step is to ask, in this idea of the story, what is each of those actors is going to do or is going to need. And for each of the actors, you can think about this story of what can happen with that actor. The Pac-Man. Oh, the Pac-Man is going to be drawn on the screen. The Pac-Man is going to move. Well, the Pac-Man move, but the Pac-Man can have a collision, with a wall, can have a collision with a pill, can have a collision with a ghost. The ghost is going to move somehow. Well, there are going to be 4 different ghosts moving in 4 different ways. Well, but the ghost can have also a collision with a wall. The ghost can have a collision with the Pac-Man. Well, in fact, the collision between the Pac-Man and the ghost doesn't matter if you are talking about the Pac-Man or you are talking about the ghost. It's the same requirement. It's the same thing, the collision between them. Well, but it could happen that the Pac-Man is in a state in which there is a power pill involved or not. When you start with the actors and you start thinking about what could happen, what you are describing is all your stories, the beginning for your stories, at least. Sometimes that stories are going to be used ready to go, correct? Sometimes they are going to need to be improved. I am going to talk about the improvement process, but that is the beginning, all the different possibilities. Moreover, when you have something like, okay, this Pac-Man is going to move, this Pac-Man is going to whatever, that sentence, that idea that you have, that you think that is a requirement, ask yourselves, why? Why this is going to happen? The answer of the why is basically to verify if that thing that you're proposing have a value for the user. If that is something that the user asks you to do. We're going to have the Pac-Man dancing in circles. We can do that. Why? Just because I want to practice my programming skills and draw circles. That do not have value for the customer. It could be something very, very cool to do for you, but not for the customer. Not a story, not something that you are required to do. Forget about it. Who? The actors. What? The actions in which they are involved. And just check for each of them that they have value for the customer. That is something that the customer wants. This process is something that is described like storyboarding. Create a story. In the agile part is think about something like this. Think about all the possibilities. Think about this like doing a comic book. Which are your actors, what they do, what is the result that we get, ask you who, what, why. Very important, when you ask what, also think about the opposite. What if? What the Pac-Man is going to do? Move. What if there is an obstacle? What if something goes wrong? What if some condition happen? What is the result? Think about the action, but all the different possibilities, particularly errors or special circumstances, because you need to describe those in stories. This is the point of view with Agile, but from your 360 class, from your introduction to software engineering, you could agree with me that what we are talking about is basically what you do when you create a use case diagram. Think about the use case diagram. The use case diagram is exactly something that can help you with this storyboarding. For the Pac-Man, one of my students do this. Use case diagram. If you're familiar with the UML use case diagrams, you can identify this. These little guys are representing when we asked before to identify the actors. And they are, the user is and the system. That is the name that my student put here. It's what you call the Pac-Man and the ghost, the intelligence behind the machine and the player, whatever name, two actors involved. And for each of them, when you start creating these use cases, the ovals, and remember, each of these ovals represent one requirement. Each of these ovals represent a user story that you're going to create. What you do here is all the different things that each of these actors need. Someone asked, what could be a correct answer for the homework? What are the stories involved in this homework with the Pac-Man? You get the idea. Most of the things that I mentioned in the previous lecture are core ideas of the Pac-Man video game. The only thing is, well, some of them were steps instead of tasks, instead of requirements. Some of them need to be put together in one thing. Some of them were too big and need to be split in order to create a story. So some of them were big or small, and you need to find the middle point for the story. This is an example of ideas for that middle point. All of this you mentioned in your homework. As a user, what I want as the player, I want to view the characters. The characters should be on the screen. Which characters? Well, the Pac-Man and the Ghost. So this view is what I described before as draw. Again, view the characters, draw the characters, verbs, and they imply something on the screen. From the perspective of the user, I want to view. From the perspective of the system, I want to draw. It doesn't matter. Characters on the screen, the labyrinth on the screen. Notice, the requirement is having the maze. No details here. The details are going to be in another place. The score, you mentioned the score. In some point, I want to make you aware that these three things here are going to become the view of the system. The characters, the maze, the score, they are going to be together in the screen that you saw when you start the game, when you are playing the game. But well, they are elements. They are part of the story, the things that the user want. Moving. And moving is a complex requirement because all the things that you describe, when you do moving, this moving is connecting with other requirements. The collision, eating the dot or the power dot, kill the ghost or eat the ghost, or game over, missing the Pac-Man. These circles, all of them are requirements. All of them can be stories. Advantage of the UML allow me to connect requirements, to use inheritance, inclusion, extension, and that helped me to somehow control the story, to figure out the story in one screen. Not mandatory. I'll just share with you the diagram to show you the relationship that later you are going to have, the integration that later we need to do. But well, moving, the elements connected with the moving, the extra things. And something similar when you think about the ghost. We already have here the draw, we need the movement, we have different ghosts that move in different ways. And this die, well, you can think about Pac-Man die or the ghost eat, depending on the name, the connection that you're going to have. When you look this picture, most of the things that are connected with the Pac-Man video game are described here. We all know the Pac-Man, but if you show this to someone, if you review this, if I ask you, you think that this is the full story of what could happen in the Pac-Man? I have a score, I have a maze, ghost, Pac-Man, the ghost move, the Pac-Man move, and well, some point they collide, one eat the other. That is the story, the parts. Yeah, for each of these, you need details. Any of this. Moving the Pac-Man, moving how? Keyboard or mouse. Doing the maze. Oh, okay, what should I do to do a maze? You need details. The details are in the back of the story. The details are, if you're using UML, in your activity diagrams or in your state diagrams. The details are something that comes later. The details are going to be the content of the methods or the classes that are going to be related with developing each of these requirements. Make sense? So what I want to do is to ask you to do something like this. Again, if you're familiar with the diagram, you can start with the diagram. The diagram can help you. What I am asking you to do is the stories of another system that I am going to share with you and working with your team. Why with your team? Because if I work alone, I can make mistakes. I can maybe put here something that someone else can tell me, you know what, this is a step. You know what, this is not one, but two. The reason because you work as a team, the reason because there is not one leader, but a self-organized team is because we trust that several people working together, several brains together can provide a better result. So that is what I am going to ask you to do. Now, the actors, the story. But again, if you start working, you are not going to have the stories correct at the beginning. You need to do refinement. Start with something, move forward to improve. Step number one, talking about improvement. Pacman. Option A, option B. I am working with the storyboard. I am working with all the different things that could happen in the Pacman video game. You already know them, so I do not need to show you. But working with my team, one of my teammates proposed this story, the story A, and someone else proposed this story, the story B. Can you tell me which of those two is better and why? I have 2 votes for B, 3 more. Okay, 1A, most of you B. Okay, B, why B? Agree with you. Element number 1, you can start your storyboard. You can start creating stories. The first thing that you're going to do with your team is go ahead, brainstorming. Tell whatever is in your brain and maybe document that somehow in a whiteboard, in an Excel data sheet, whatever. Put the ideas. Once you have the ideas, now we can start with the refinement. Step 1, when you have a story and your stories are going to include who and what, common error. Think about the who and the what connected. In this example, if I think that the ghost wants to move, it's a direct connection. I am the ghost, I want to move. The system, and the system need to implement somehow moving the ghost automatically. That is a direct connection between who and what. The A, I am not telling you that the A is wrong. However, it's not exactly the best way to represent things, because as a player, I am the user and I want to see the ghost moving. So I am the player and I want is that this other actor do something. That is what I am talking there, versus I am the actor and I want to move. The A, you have 2 actors, the player and the ghost. In A, what you want is another actor to do something. It is not your responsibility to do that. It is not your responsibility to wish for the ghost to move. Think about it. You are the Pac-Man. You are the player. Best case scenario is having all the ghosts stop without moving, because then you can accomplish your goal of eating all the pills. You really don't want the ghost to move. If you have them stop, it's better for you. Now, the one that want to move is the ghost. So really the story here is B instead of A. Review the connections, important. Now, okay, we review the connections. We ask for any question that we could have. Anything could be ambiguous. And if we have a question, the final decision is the customer, not the team. This is not a democracy. It's not like 3 understand something, 2 understand something else, 3 win. Ask the customer. What you are going to do is now, whatever thing you think is a story, I am asking you to follow this template. This is the template for the stories. Maybe you're familiar with it, maybe not, but the template is very simple. As the actor, you already identify your actors. I want to, the requirement. This is the place for the requirement. This is the place in which you put move, draw, collision, whatever. That is the place in which I am going to read the requirement, but now I am reading also who is the actor, who is the role in the system that is connected with that requirement. If you check the use case diagram here as a user, I want to view a character. As a system, I want to move the ghost. Requirement, the oval, the actor. Obviously, you do not need to do this diagram in order to figure out these stories. In the material that you have for the Pac-Man, I am sure that you can read what you submit, and could be very simple to just transform what you submit to this kind of format, this kind of template. You already know that you have only 2 actors, the player, the system, the Pac-Man, the ghost. And whatever you submit before is, I want to, and put there the sentence. Now, again, the third element in the template, so that I can, let me be clear. The third element in the story is, tell me why this is valuable. The value of this. I want to do because. What is the value? Very good question in the chat. If you have this story about draw the ghost, who is going to be the one drawing the ghost? Depending on the perspective that you follow, you need to be consistent with your perspective, with your story. But I could think about the following as a ghost. If you're thinking about the ghost as an actor, option number 1. Option number 2, as a system, I want to draw a ghost. Again, depending who you define as your actor, the system, the ghost itself, just connect them, make sense. You have only 2 options with the Pac-Man, the system and the players, or the Pac-Man and the ghost. Use those 2, and with those 2, connect the stories in a way that makes sense. Yeah, I am telling this before. You can talk about the Pac-Man or the player. They are the same. And you can talk about the ghost or the system or the engine. They are the same. We're talking about the same actor, right? I mean, if I tell you that the Pac-Man is the player want to move. Well, the Pac-Man want to move. It's depending where you put the responsibility. It's depending of how are you identifying the system. Remember, the actors can be users or systems. Systems like an intelligence inside of the computer, or systems like information that you get from the cloud. They can be actors. When we define actors, we are not talking about the stakeholders. That is not the point. Actors are not stakeholders directly. Actors are these elements in the system. One of them, the player. In the particular case of the Pac-Man video game, the player is the Pac-Man. They are the same, right? The Pac-Man is the representation of the player inside of the computer. And the ghost is the representation of the system in the computer. The ghost is the system, is this enemy that is attacking me as a player, as the Pac-Man. So two actors, you can use the name that you prefer, and therefore your stories are going to follow that path depending on the names that you use for your actors. I am using Pac-Man, I want to be draw. I am using player, I want the Pac-Man draw. It's the same requirement. Well, remember, something that we are doing here is moving and drawing, two different things. Because we're talking about this drawing appear on the screen. And we're talking about this moving, about calculate the next X and Y position. Moving and drawing are going to be connected, right? I mean, you're going to have something calculating the next move, the next XY coordinates. And this entity that the only thing that it's doing is figuring out the next X and Y, somehow is going to be communicating or working together inside of the system with another entity that is the one doing the drawing. I am going to calculate an X and Y coordinate, and then I am going to ask, hey, you the one that draw things, draw something in this position. But there are two different requirements, drawing and moving. Think about this. The first version of your Pac-Man could be used, draw on the screen the maze, the Pac-Man at the center, and the ghost in the corners. Drawing, nothing is moving. A next version, a next iteration is, okay, now let's work in the moving. The moving is not the same as the drawing. They are related, but relationships of two independent things. Yeah, if you want to think about this design level, you can be thinking like moving is the model and drawing is the view, if that helps. Yeah, the model is the one calculating the coordinates, and the view is the one showing something in those coordinates. And the something happened to be a Pac-Man or a ghost. Yeah. Good? So, 1, the storyboard. 2, brainstorming. Any idea that you could have, put there. 3, follow a template. The template identify 3 things: the actors that you previously identified, the requirement connected with that actor, and somehow justify why, the value, why you are doing this. Please remember, the requirement is here. The requirement should be after that I want to. Common error, put a requirement here so that I can, and suddenly there you have a requirement. Be careful. The requirement should be in the middle. The requirement is after the I want to. That is the sentence that tells me the requirement, not the others. Okay, I am going to work on this. I am going to create stories, and I am going to follow this template now. What else? What else? Common practice. In Agile, you put these requirements in kind of a piece of paper in the front, and you can think that in the back, you can go with details the most important one, testing. How can you verify that that requirement was done? Did you notice that I am enforcing the value for the customer and I am enforcing the testability? Two ideas of the invest used in the definition of the requirements. Let me be clear. For the UML here, you know that for each of these, you can have an activity diagram. For each of these, you can have a state diagram. It is not mandatory for each of them, but those are the two options that you have to specify details, to specify steps. Another diagram, not for the full diagram, but another diagram connected with one particular oval here. When we talk about stories, when we talk about this template, usually the idea is, well, you have this, the story, and think about each story can have details. Each story can have more information. More information, text, more information, a diagram is valid to do that. Use more information, and usually the information about the steps. For instance, moving the Pac-Man. Moving the Pac-Man, how are you going to check that the Pac-Man is moving? Well, I want you to move the details, the back of the car. I want you to use the keyboard. And the Pac-Man should move up if I press the arrow key up. And the Pac-Man should move down if I press the arrow key down, and so on. And that details are telling me how to test it, how to verify, but also what is expected me to implement moving with the keyboard. You know what? In order to check that the Pac-Man is moving, you can use the mouse, move the mouse, and the Pac-Man should move in the direction of the mouse. Okay, you are telling me that in order to implement the details is that you expect also to move with the mouse. The criteria for verification is what I need to accomplish. So the story, the big title, the oval, and then the details come in a different part, in the back of the car or in another diagram. Be careful with the details. When you have this, obviously, step number 3, the one that I mentioned before, the invest principles. When you have something that already follow the template, when you have something that already you check that is a direct connection between the actor and the action, now you can use your time to check for the invest. Yeah, tell me, I have one hand up.
Yes, sir. So in the previous one, when you're saying that we need to write the verification statements, so let's imagine the requirement is moving a Pac-Man. So we write that if you press the up key on the keyboard, it moves up and all that. So do we need to write that as well, that if we are moving mouse, it should not move? Like if it's not in the game, are these all test cases or just only requirement that, okay, it should happen like this?
The minimum information that you need to provide to a developer in your team.
Okay.
The smallest, the better. For instance, if we are not expected to use the mouse, we do not need to mention that.
Okay.
It's just, you can just say, move with the arrow keys in the keyboard, period. We do not need to go with the details, up, down, left, right. Any keyboard have only those 4, so we expect that the developer, the member of my team, understand. One of the ideas with Agile is the minimum you write, the minimum someone else needs to read. Do not make other people to read one page. If you can put the same information in 2 lines, think about the opposite. You will appreciate that someone else put in 1 line something that you need to know instead of asking you to go and read a full book, right? This is a lot about that. So moving forward, invest is your step 3. We already talked about this. We reviewed this in the previous lecture, so I will assume that you're familiar with each of these letters. The only thing that I want to mention here and be very, very clear, a common error that the people do is to mix dependency with relationship. Let me try to explain this. We have Arizona and we have Florida. And these two states are independent. However, they have a relationship. They are part of the same country. They have a relationship, commercial, whatever, you put the name. But having relationships, having connections, calling a method in another class, or receiving a parameters another object, that is collaboration. That is having a relationship. But that doesn't mean that we have a dependency. You can have two requirements that are independent, like drawing and moving. They are independent. Drawing is draw the goat, draw the Pac-Man, and I do not need anything to draw them. I do not need anything to draw a circle in yellow and all the details. Moving is independent. Moving is about calculating the next X and Y position. And I can calculate the X and Y position randomly or with a particular algorithm, whatever. These two things happen separate. They are independent. In the game, they are related. There is some kind of collaboration between these two. It's like, okay, I am going to calculate the next position, and then I am going to ask you to be drawn in that position, so we achieve a common result. There is a relationship there, not a dependence. Think about this. If you can have two programmers, one doing this, A, and another doing this, B, and later you can do integration, that is a case of a relationship, not dependency. What is dependency? Dependency is that you have these two things, and the only way to achieve these two is having the same programmer, the same people doing both, because they are two related that cannot be split in two different things that later we can integrate. Makes sense? Do not mix dependency with relationship. Classical example, moving and drawing. Be careful with that. Talk with your team about, okay, these two are related or these two are dependent. If they are related, you can say, check, they invest, we are good. If they are dependent, well, that is not a requirement, remember, because they should be independent. Maybe the most important one that I would recommend you to review, because value, you already review it when you were writing the story. And testing, you also review it when you were writing the story, because testing is here, value is here. All of them are important, but one that you need to care about in particular is this one, detecting what is the situation. Okay, so you are going to ask me to create stories, a bunch of stories, brainstorming, and then I am going to review this invest. I am going to review this direct connection here, and I am going to clarify any question that I could have, because really the customer is the one that know the things. Moreover, now the new thing, you are asking me to identify who? Actors. Yep. What is going to happen? You're going to do that, and that is the first step, the first stage in your homework, the first stage in your work. What you're going to have after doing all of this, some of the things that you create are going to be stories. Some of the things that you create are going to be ready to go, but others are not. The stories that you create that are good are called the stories. The stories that you create that are too big are not small, are not invest. This is like a good story, but it's not independent. It is not small, cannot be tested, whatever. Any of the invest is not there. What you have is something that we're going to call an epic. An example. You agree with me before that that is not a story. You agree with me before that this is too big. It's like, yeah, I want the game done. This was the problem that you want to solve. It's not a story. It's not something that we can use as a requirement. Uh, as stories, I am naming my requirements. Stories are good. Stories are requirements. This guy here is not a requirement. This guy here is not following the invest. However, that guy there is important. Why is important? Because it's information about something that I can improve. Okay, I know that the user want a Pac-Man video game. I can start with this. And starting with this, what I need to do is refinement. What I need to do is improve that. Somehow move from this epic to one or more stories. It's not a requirement. It's not a story, but have some value. We need to keep it. And we're going to keep it. And these things, we're going to call it epics. Okay, so what you're telling me is that I am going to start talking with my customer or reading the requirements. And then I am going to do brainstorming. If I am lucky, I am going to create requirements, these small things that are ready to go for production, that I can put in a particular sprint. But that is not going to happen always. Something that is going to happen is, well, sometimes I am going to have things that are still unclear or not independent or do not have a clear value, use ideas that my team is going to have. When they are too big, they are called epics, ideas. Your work is to move these ideas to stories, but you start with something. Sometimes we talk about epics and stories, only the big one and the small ones, but sometimes we talk also about the medium ones. The medium ones, we call it features or themes. Just like that. They are small than an epic, but still they are not stories. You can move from one of these to several of these, or you can move one of these to this and then to this. There is not really a connection. There is not really from epics to themes to stories. And you can go from the big one to the small ones. It's just depending on your team. Is this brainstorm? The only thing is you need to be aware that these are important, but these are your goals. So brainstorming, big ideas, small ideas, but the goal is that the small ideas, these are the ones that we're searching for. You need to work with your team and move all these things to only this. Key. because I am talking about the split things. I am talking about big ideas, things that do not follow the invest to stories. Keep in your mind when you are working with your team this slide. I don't know if you get the message here. With Agile, your goal is to deliver software quickly. But when we talk about deliver software, when we talk about giving the user a version of the software, hopefully you get the idea that from the user perspective, what the user wants is something that works. As a user, I am expecting a car. Okay, that is my final goal. I need to wait. But as a user, I am going to be happy if you give me something like this. Why? Because something like that can move. It's something that I can start using. Okay, I do not have a car, but at least I have this device and I can move from my home to the campus. It is not my final project. It is not my final product, the one that I want, but it gives me a service. Common mistake. I am working with Agile and I am going to work on this in my first iteration. Yeah, you will need that element. But if you develop that element, it's not useful for the user. Think about this. When you are showcasing your project to your professor, if we are working in a capstone project and you tell me, Professor, we have everything done, but my partner here have this part, my other partner there have the other part, and I have this other part, but we haven't integrated things, so we cannot show you anything, but we're working. That is not Agile. That is not what your customer wants. When you split the epics to stories, keep this in your mind. Later, we're going to talk about priorities, and we need to keep this in mind also with the priorities. This is not useful. We're not doing the parts of the thing. We're creating a product that should evolve, but from the beginning to the end, provide some functionality that the customer is expecting. Anyway, yeah. Key idea. Remember this when you split stories. Now, splitting stories, well, very simple. Step number one, start with the storyboard. Step number one, start with something like the use case diagram. Step number one, identify your actors and ideas of what those actors are doing. Step number two, some of these are going to be ready to go stories. Some of them are going to be things that you notice that they are not following the invest. Again, any of the letters is not there. If any of the letters is not there, they are not stories. So we can think they are these epic things. Your work with your team is all about, if I have this, split one or more. Be careful, because if you split a lot down, storyboard, the epic, the stories, but if you go down, here you have the steps, and you do not want to go to the steps. You need to split this and move to stories, but be careful. Stop as a story. Do not go to an instruction in the program. You're splitting your project in components. You need to stop in a class or in a method. Do not go to lines of code. That is maybe my analogy, my best analogy for this. You do not want this. You do not want this. You want to find these guys, the stories. It's a brainstorming process. I give you some hints. At the end, it's all about your skills and this idea of talking with the people, and 2-3 people are going to have a better idea of how to keep things here. Ideas of when a story become a step. Help me to answer that. How do you know that a story become a step, that a story is too small? Yeah, good. Uh, well, remember, this idea of estimation, we need to talk more about it and how you are going to do the estimation. Right now, I am being too general, but when you think about estimation, the goal is this. If I am reading something and I am able to estimate, it's because I have a clear idea of that something. It's testing my understanding. Right now, it's just about giving you hints, ideas of how to identify that something could be too small or something could be too big. If you cannot estimate, like how many times do you need to do the Pac-Man video game? I do not know how to start. Okay, this story with I need a Pac-Man video game is too big because we cannot estimate. How many times do you need to draw the Pac-Man? Okay, drawing the Pac-Man, well, maybe a class and a paint method and drawing a novel. And I am not sure, but yeah, it's something that I can do. It's going to be a class with a method and I do not remember graphics. Maybe I need 1 day or 2 days. Okay, that could be a story because you are able to understand what are you going to do, what is involved, and you need some time, less than a week. What do you need in order to implement this, increase the score? Use a plus plus in a variable. Well, maybe that increase the score is a step, not a requirement, because can be embedded in a requirement. Global ideas. Move the Pac-Man using the keyboard. Well, two stories. What I did before is like that example I put here. I have a similar idea about moving the Pac-Man. I do not add the using the keyboard. That I can put that in the testing part, but moving the Pac-Man, and then I put in a different story the collisions. These two are connected. In the particular case with the diagram, you can use inclusion or extension. So I am representing this connection with the extension, but they are two stories. Again, I need to move the Pac-Man, something that I am going to do, and thinking about how this is going to be assembled is I can be moving the Pac-Man here and something is going to happen in a class, something is going to happen in a method. I am calculating new coordinates for X and Y, but I need to check for a collision. And maybe something that I can do is just call a method and send that method my coordinates, or the coordinates in which I am going to move. And that method, that responsibility can be in a different part. They can be independent, moving, checking collision, related, but not together. Two stories, two requirements, two people that can work on this. Yeah, related but independent. Yeah. That is maybe one of the main things that you need to think about it. Dependency is very different than relations. In your class diagrams, you have association, composition, inheritance, and so on. Those are relationships, but the classes involved, they are not dependent. I mean, not because those relationships. We need to review that later with the design. Good. Okay, so it's like dancing, literally, between having an idea, having a project, and go down. And if you are lucky, you go directly here. But if not, you are here. And if you are here, trying to go down. And if you go too down, go back. And somehow in this movement, getting a correct answer, an agreement with the people involved. And that agreement is, validate the invest, validate the actors, following the template, and in doing so, the value and the testing again. That is what you do to start. Clear. Not too low, not too high, in the middle. Okay, so doing so, what you are going to create is a bunch of stories. And those stories can be represented like this, like a whiteboard with all these cards. And our next step, not today, but after we have this, then we can move forward. And for each of these requirements, for each of these stories, we can meet with our team again, and we can put a priority, which of them are more important than the others. And also we can quantify the level of difficulty. How many hours do we need to accomplish them? And these two things are our next topic. We need to talk about priorities, and we need to talk about quantification, because we need to do this before start with the sprints. After doing this, basically, we are going to have stories with high priority and stories with low priority. These are the important ones, because with this, we can move forward and start planning our sprint one. And in the sprint one, well, we need to put those stories that have high priority, the stories that are related with them, and we need to think about the difficulty level, because well, we're going to try to put in the sprint as many stories as we can, but we need to think about how many hours do I need to accomplish them, and how many hours, developers hours, do I have. At the end, I am going to create a sprint. The other stories are going to wait for another sprint, and so on. But that is a different lecture, a different story. The first thing that I need in order to move forward to sprints, or even to quantification and prioritization, is to have the stories. Your homework. I am going to send an email to each of you, and that email is going to include the names and the emails of your teammates. Teams are going to be 6 or 5. You're going to receive that email in 5 minutes. I close the lecture and I'm going to start clicking send to the email. So the email comes from my account and have names and emails of the people that you're going to be working with. So you can communicate, maybe organize a meeting or whatever. And what I am going to ask you to do is to review the following project and create the user stories for the project, following the process that we described today. Answering the chat, that make a requirement. A requirement is, number one, for you to have the Pac-Man eating the cherry. That is something that, for instance, I do not add in the diagram that I show you. I just consider eating the power thing and the small things. I do not consider these extra elements, the cherries. So that could be another requirement. And the requirement itself is for the cherry to exist, and then for the cherry to have a collision with the Pac-Man, and then for that, after the collision, give you points in your score. So is one requirement? Yeah, the part that is only getting points in the score is one step, but is one step in this requirement, the cherries. That can be added with the one that I have with the power pill and the other pill. So we can add there a connection with the cherries, the story for the cherries. Good. So here, I am sharing with you a video. This is the final project for one of my classes, 360, Introduction to Software Engineering. So basically it's a video in which I am explaining to my students, undergraduate students, their final project. You're going to notice I am going to explain basically graphical user interfaces and functionalities and so on. You can go use to this is 28 minutes of explanation. You can move starting to the minute 26. That is the point in which I start with the project. My request for you, check the video. You can do it individually, take notes about what is the project about. And then my request is work with your team and create the user stories for that project. This assignment is going to be graded, and this one is going to be graded now, not only for the submission, like the previous one, but now we're going to grade your understanding of what is a story. I am not asking you to submit epics. I am not asking you to submit the steps. Everything that you submit are the stories for the project. And now you know what are the features of a good story. Yeah, that one, the ghost IE, is what I call move the ghost. That is the name that I use, moving the ghost. And for moving the ghost, I am going back to the diagram. I consider this moving the ghost is the principal requirement, but I have 4 different kind of specialization things. And each of these is what we can call the artificial intelligence, right? Because we really have 4 artificial intelligence or 4 algorithms for moving the ghost. According with the color, they move in a different ways. They follow different strategy. So that one, the artificial intelligence, is what I am representing in this part of what I split in these 5 stories. Well, you have an algorithm, right? I mean, it's like, number one, you are asking the ghost. One of the algorithms is following the Pacman. So testing, run the program, and the Pacman move in a particular way, not necessarily for a user. I mean, you implement this testing scenario, test bed, in which you move the Pacman with a particular path, a particular coordinates automatically. And the only thing that you do is to check that the position, the next position of the ghost correspond to what you expect following the Pacman. I am representing this graphically, but remember, moving the Pacman is numbers. And the algorithm that calculates the next position of the ghost is calculating numbers. So you have these numbers as an input and you have these numbers as an output. And basically what you need to test is they match. The output of the numbers for the Pacman after you apply your algorithm match the expected output, that this ghost is following the Pacman or whatever is the goal. So it can be tested. Good. And it can be tested without the Pacman, because again, you can have these objects creating random values for the Pacman on a particular input that is the Pacman, and having your algorithm creating output values for this ghost that you are not drawing either. Obviously, you can then put the draws there and you can have a human being playing with one ghost, or then add all of them for a user experience testing, but different story. Good. So these slides are now on Canvas. You can take a look. Any question, let me know. And again, I am sending you right now your teams. Start working. You have 1 week. You have 1 week. Only 1 team member submit. And again, you submit. Please put your names in your submission. It's something that I put here. Only 1 person submit. Put your names. Obviously, I am assuming that you are going to put the names of all the people that I am sharing with you, all your team. But if for any reason someone is not available, I have 2 or 3 people that even though they are enrolled, they have not been attending the lecture. So if that is the case, if someone in your team is not available, do not put the name. So we know that you are, instead of 5 or 6, you are, I don't know, 1, 2, 3 people working. So we consider that when we start grading. Good. Any question, guys? I am not giving you a number. I do not want to bias your work. It's a project that I ask my undergrads to do. one of the first things that I am going to review with you, one of the first things that is going to impact your grade is the number of stories that you create, because obviously I know the exact number of stories that you should create. Plus minus 5 could be good, but I am curious if you go to several, a lot, 100 stories, or to too few. That is going to give me a sense of your understanding about epics and steps. So I am not going to mention a particular number. You need to have stories, and each of the story should be validated for the invest, right? Remember, a story is something that follow all the invest principles. So the stories validated, stories that are not too big, not too small, stories that I can use to start my sprints. So yeah, please validate and follow the template. I want, because, follow the template. Now I am asking you to follow the template. Clear? Okay, guys, I am going to stop here. Thank you. See you next week.